Well, thanks for having me here today. In a minute, I'm going to wander a little bit because it's the only exercise I'm going to get today. But I thought I would start in one spot and then move around a little bit. One of the positions you didn't mention was I was also CIO at the Walt Disney Company for a few years. It was a real Mickey Mouse organization, and I left there to go to Microsoft. But it's relevant to this conversation because like my entry into the federal government, and OPM happened shortly after I got here last year, in the first few months of my role as CIO at the Walt Disney Company, we lost an entire data center. It was kind of a monumental experience if you're the new CIO and you get a call one day that the entire data center has gone down. Lightning actually struck the data center and blew up all the switch gear and all that sort of stuff. So we had a massive rebuilding effort. But it's events like that that make you, I think, hyper aware of the role of infrastructure, the role of training, the role of making sure that, you know, in even the worst circumstances, people not only know what to do, but they've practiced it and have a game plan. So in that particular case, we didn't lose a bit of data. Within a few hours, we were actually up and running in our alternate data centers, and no guest at Disney World or anybody who did business with the Walt Disney Company in that particular case even knew that there was anything that had gone wrong. And that was, to me, the measure of good planning and good work, all of which I had nothing to do with because I hadn't been there that long. So I got to give credit to my predecessors for doing a really good job. So about a little over a year ago, I arrived in this role, and I knew I was going to be spending a lot of time on cybersecurity because as a CIO, that's just what you do these days. It's become an important part of the role no matter where you work. I didn't know how much it was going to become a core of our work, but it's also led to a bunch of other discoveries, many of which you probably had already guessed or already knew. And the first one is that cybersecurity is not by itself an isolated thing. One of the underlying root causes, I believe, for cybersecurity challenges is aging and out-of-date infrastructure and applications and environments. And as we started looking at what we had, the sort of as-is starting point for improving security and I would say also resiliency and so on in the federal government, we discovered and uncovered a bunch of really old aging apps and infrastructure. And these are inherently things that are hard to defend, and almost everything one does is sort of the functional equivalent of putting airbags and Band-Aids on an existing environment. And it's just hard to get good cybersecurity when that's the mode that you're in. But let me illustrate the case a little bit further. It was also not mentioned that early in my career I worked at Sun Microsystems, and one of the first projects I had a chance to work on was the first generation of SPARC servers. This was the reduced instruction set chip that Sun worked on. And this was an exciting time in the computer industry. It was the beginning of really high-performance workstations and so on. And we produced a series of SPARC workstations and also SPARC servers that got quite a nice foothold in the industry. I worked on the team that shipped those first servers. I left Sun Microsystems in the mid-90s went on to other roles, some of which were talked about here today. And Sun ultimately, as all technology companies do, end-of-lifed those first generation of servers in the early 2000s, mid-2000s for some of them. So you can imagine my surprise, and end of life means there's no longer support, there's no longer software upgrades, that sort of thing. So you can imagine my surprise when I got here to the federal government and found out we've got a ton of those things still sitting around. The good news is they're continuing to run. The bad news is they didn't break and didn't get upgraded or didn't get replaced. And this is, unfortunately, the paradigm for how we think about, all too often, the critical applications and infrastructure that run the federal government. It is a wait till it breaks kind of model, or wait till there's some sort of event that then it becomes compelling. And I believe in today's world, that's the wrong way to think about these things. Just as the previous speaker was discussing, I think we need to move to a model that's continuous upgrade, continuous replacement, so that you're never more than a few years out of date. And the benefits of this, I think, are obvious to most of us. The simple math is this. Every few years, Moore's Law still continues to deliver on its promise, meaning that you can buy the same, for the same dollar, often double the capacity in a 3 or 4 year kind of period of time. Moore said, I think, every 18 months, but I'm putting a little overhead in the algorithm there. But let's say, conservatively, every 2 or 3 years, you can get double the compute power, double the processing power for the same dollar that you spend. It means over a 10-year period, you've lost 4x if you're just sitting on the old stuff and not upgrading. And the choice that you have is, and these are law of large numbers, but I know that if I spend $1 on information technology, it's going to cost me 15 cents a year to maintain that for support and for other operational kinds of things, on average. So if I wait 10 years, I'm still paying the 15 cents per dollar spent, but I've missed 4x in terms of the capacity or compute power that I could be paying or could be getting, and I could still be getting support for that same 15 cents on a dollar. So the math is incontrovertible that we should be upgrading, we should be replacing this stuff. It gets even worse when you look at network, it gets even worse when you look at storage and the other building blocks that we build information systems out of. So in essence, the federal government, by sitting on our hands all these years and not upgrading and not replacing, have missed out on multiple generations of opportunity for higher performance, better bang for the buck, but we're locked into that 15 cents a dollar on the original investments that we made a long time ago. And the even more bad news is that 15 cents gets higher and higher and higher the older the stuff gets, because you have fewer resources that know that technology, spare parts are harder to find, people who know how to configure and maintain and manage that get old like me and are ready to retire, and the problem just gets worse over time. So I tell you that story because it's the motivation behind the newest proposal we have, which is for the IT Modernization Fund. What we've asked Congress for is $3.1 billion in a one-time investment for modernizing critical applications and infrastructure in the federal government. And the way it would work is like this. If you're an agency who has some of this most critical and insecure or hard to manage and inefficient applications and infrastructure, you can apply to the fund and make a business case for doing so. You'll get incremental funding if you're approved, if the project is approved. You'll get incremental funding as you hit deliverables and milestones. And then over a 5-year period of time, you'll pay back the fund. Now, if you're in the private sector, that doesn't sound like an unusual construct. Every time I was asking for capital investment in the private sector to do something, it came with the understanding that whatever that capital was would get depreciated or amortized over a period of time, but it was going to have to be paid back somehow. In the federal government, that hasn't been the case. The way appropriations have worked in the past, you would get a one-time shot, and that's it. And you were expected to do the job, but often management's attention drifted off to the next thing that they were asking for money for and not on getting the thing delivered that had been asked for in the first place. So this is a mechanism to both fund needed upgrades and replacement, but also to keep management attention focused on the delivery of the critical applications and infrastructure as the work gets done. And replenishing the fund sets it up to fund the next set of projects. And so we think we can address $15 to $20 billion worth of applications and infrastructure over a several-year period, all for that one-time investment. So it's a pretty important initiative. We're getting great support from both sides of the aisle, and I hope if it comes up as a topic in any of the places that any of you show up, you'd be able to support it, because I think it's a dramatic change from what we've been doing. So let me end that topic, and I think you can tell I'm pretty excited about that. On several other fronts, I think there's more work that we have to do. And I want to call to your attention one of the things that I've been talking about for a few months now. And this all has to do with architecture and design. Now, I'm not going to get into a long sort of engineering discussion here about how to go build things with a lot of detail. Instead, I want to talk about a reasonably high level concept that I think you'll all relate to, whether you're a technical person or not. And that is the fundamental nature of how we build things today, I think, is fundamentally flawed. The basic architecture still relies on chips, operating systems, network components, storage, the basic building blocks of how we build applications and infrastructure hasn't changed in roughly 30 or more years. And all of this was designed at a time when we didn't face the cyber threats that we face today. The dominant theme among the technology builders of these components has been massive interoperability through the use of standards. And we have fulfilled that promise big time. You can take almost anybody's thing and have it interoperate with anybody else's thing, because they all do standards in a pretty solid way today. Any storage can attach to any compute, any network can attach to anything else. It's all great. And the question is not whether you can interoperate with the other things in your ecosystem. The question is, should you? Is that thing safe? Is it what it represents itself to be? Do we have a trust model that makes sense and can scale across all of the things that we do? That's the big issue, I think, that's facing us. Especially in this Internet of Things world, the question more and more and more is going to be, should I interoperate? Should I take information from? Is that thing a danger to me? Does it represent a risk that I can quantify? And those are all critical questions that we're going to have to answer as we build out the architecture and infrastructure and ecosystem that will enjoy great benefits from, no doubt, but we also have to be worried about the other side. And so I'm excited about a lot of the R&D that's going on that's helping further create models and understanding in those spaces. But I think it is something that we need to pay attention to. And I think there's one more change that's required, and that is building in more resiliency into the building blocks in the first place. Today, most chipsets and operating systems, networks, and storage gear, and all the other components that we build things out of lack a couple of critical features in my mind. The first is self-awareness. And by self-awareness, what I mean is, am I healthy? Do I have all the pieces that I need? Am I still operating in the way that I was designed to operate? Have I been compromised in any way? Am I being asked to do something that's not what I should be doing? Can I communicate to other things in my ecosystem whether I'm healthy or not? And just like the human body, if there's something that does go wrong, can I call and get defensive help to come heal and fix myself? Or, on the other hand, take me out, coach, get me out of the lineup, substitute somebody else in who's healthy. Those are all characteristics of, I think, healthy building blocks to build systems out of the future. And those principles could apply to networks and storage and all the other building blocks. I'm very worried about a trend that I see, and I'm, by the way, a big fan of big data and all that sort of stuff. But I don't believe we can collect logs and analyze them for everything that's going to be a participant in the Internet of Things. I don't think there's enough compute power or enough data science to do that effectively at really large scale. I think we can use all those tools effectively for some things, but not for everything on the planet. It's just an intractable kind of problem. And so we need building blocks that are more capable of taking care of themselves, of protecting themselves from bad things, of reducing the amount of logs that get generated so that only the things that are really interesting and really need to be analyzed are the things that get generated, not every single event, as one example. And this is not a criticism of any company that does log analysis or any of those kinds of things, because I think in the short run that's going to be a very important vector for us. But in the long run, we need more R&D on coming at building these things and designing these things from a different design point than where we've come the last 15 or 20 years. So as you have conversations in your various industries and with your various colleagues, I think this is something that we should be talking about. I've used the analogy before. It's like trying to take a 65 Mustang and retroactively put airbags in it. You can imagine what that would look like. It would be pretty ugly. It might be reasonably effective, but it would probably not enhance the design of that 65 Mustang. You can imagine that 65 Mustang with a lot of sort of bubble wrap all over the place inside it, and would take away from the design. But if you look at a modern Mustang that's been designed with modern technology in mind and modern airbags and so on, it doesn't detract from the design at all. It makes it a very safe automobile, just as many others are. And I think it's going back to this core design point that we need to do and rethink how and why we build some of the things that we do. So with there, I'll stop. I hope I've left you with some information that you can use, and I'd be happy to take any questions that you might have. Quieted the crowd again. Here's one.
David Winks with ICIT. As we think about the networks and what we're putting together, we have things like Einstein, and we're trying to cleanse all of our traffic. Yet we have folks at various agencies that can just order up an internet circuit, and then they just connect it into the network
Sure.
and bypass all of that infrastructure. How do we get a handle on that?
Well, I think there's a lot of ways it can be helpful. One of the things that we're trying to do is get each agency out of the business of doing 100% of what it has to do, particularly in this space, from having to do them themselves without knowledge. So today we expect the smallest federal agency to do exactly the same work in terms of protecting itself as even the largest agencies with lots of resources. So you can imagine DOD down to, some really tiny agency, and they both have the same tasks to do. Obviously, one's going to do a different job than the other. So one of the things that we fundamentally believe in is much more shared services that you can do at scale, where you can bring the expertise, bring the folks who really know how to do things well together, and provide that as a set of services to smaller organizations. So I think that'll help. It'll take some few turns of the crank to get it fully operational, but I think that's a big deal, and it's part of what we suggested in the CNAP plan. But beyond that, it's I think some of the other things I talked about, which is, the more self-awareness you can build into the components and so on, you can begin to sort out, am I being asked to do something I shouldn't do? Am I configured in a way that's not correct? Am I part of an ecosystem that doesn't seem to be healthy here at the second? And if you can report out that kind of information, it's very, very valuable, as opposed to just sort of lying there, sort of waiting for something bad to happen. So I'm hopeful that on both fronts we can make progress.
Irvin Reeves, the Graybeard Group.
Yeah.
How do we get Congress to understand the magnitude of the problem that they've ignored for so long?
Well, we're working on it, and I'll tell you, FITARA has helped. For those of you that aren't into the lingo of Washington, we got a law last year called FITARA, which was the Federal IT Acquisition Reform Act. And one of the things FITARA did, and I want to thank Representative Connolly and Darrell Issa for really pushing this, is it in law created much more visibility and transparency of IT spend, and it solidified the role of the CIO in the agency, requiring sign-off and approval not only for expenditure but also for people decisions and other kinds of things. And the game in some agencies, quite frankly, was hide as much as you can. Barry we're going to see some ugly truths come out as we get visibility and transparency of what's really going on. And I saw this in our cyber sprint this summer. We had some initial responses on PIV card adoption. We'd get a call from an agency and say, hey, I just got up to 60, 70, 80%, whatever it was. And then 2 hours later, they'd say, oops, we just discovered this other component that isn't there. We got some more work to do. Now, overall, we've made great progress, but I've seen this happen over and over again where, as we get better at looking at things and examining what we have, we find that we have more work to do. And I think this is going to be true of Congress. At first, we're going to see a lot of things we wish we didn't have to see or we didn't have to go look at. But once you have the truth, then you can begin to move from, oh boy, that's ugly, to what are we going to do about it? You can no longer be in denial. And our approach with Congress is, let's share the truth, and then let's, as quickly as we can, get to the what are we going to do about it. And this is going to take a bipartisan effort and sustained over some period of time. It's not going to get solved overnight.
So what do you feel is the best way to incentivize the hardware and software developers to adopt that approach?
of like self-sustaining and self-aware systems?
Well, there's great incentives for the tech industry to invest in this continuous refresh model. So I don't think the tech industry is necessarily going to be the problem there. I think the bigger issue really lies in some of these underlying architectural issues about the core design of the building blocks. And that's going to take R&D investment. That's going to take work from NIST and from other places to help clarify the thinking and clarify what's useful and what's not, and so on. So I'm not so worried about the tech industry in terms of continuous upgrade. I am more focused on tech industry for the underlying architecture. One more thing on Congress as well that just occurred to me is this IT Modernization Fund that I talked about fundamentally changes the way appropriations are done for information systems in the federal government. So for those of you that are not in OMB, here's what happens. In most cases, IT infrastructure is never directly funded. It always comes as and that's applications and infrastructure, it never comes as a direct question to appropriators. What appropriators vote for is a program. They'll vote for programs in Social Security or programs in the Department of Education or programs in U.S. Department of Agriculture. And as a part of that program, there's some ongoing operational expense for information systems, and then sometimes there's a request for additional funding for new application development. And all the initial requests come in and get bundled together, and that's what Congress votes on. So they never ever directly see the underlying IT costs. And that process has kept hidden from Congress the dire circumstances of some of these systems. Now, if you look at it from the agency side, what's happened is you'll get somebody, and I'll just pick Department of Agriculture, who's put in a request year after year after year to upgrade something, and it gets prioritized with 100,000 other things in that agency, some of which may be more politically interesting or exciting than upgrading, infrastructure in a data center or something. And that request will get cut. If you're that official in the agency and you get cut 10 years in a row, after a while you stop asking. You say, why am I wasting my breath? Why am I wasting the time to put in these proposals that I know are going to get cut anyhow? And so you stop. And that's the kind of culture that, over a long time we've created. So what we're asking CIOs to do now that's different is look at all their critical, mission-critical, high-value assets. Look at them in terms of what the remaining useful life, if any, is of those applications and infrastructure. And then tell us what it's going to cost to upgrade or replace those. And by doing that and collecting that up across the government, we can begin to get a sense of what the real demand is for that and make it visible so that no longer you can sort of hide behind it's this program or that program. It'll be visible and obvious that we need to go do something. And so that's one of the things that we're doing that's different as well.
Hi, Mr. Scott. I'm Meredith Summers.
By the way, this side of the room won for questions. You guys are all reading your phones or something over there.
My name's Meredith Summers, and I'm with Federal News Radio. And I was wondering, within the fund, is there a plan for teaching people how to use the new IT? You talked about a new Mustang, or at least a Mustang with airbags. How are you going to teach them how to drive it?
Yeah. So I think the way you have to think about this is we have a problem in the federal government, just like most private sector companies do, which is if you've been around for a while, like General Motors or the Walt Disney Company, or even Microsoft, which some of us still think of as a new company, but it's not, you have a certain amount of old stuff that you've been running for a long time. And at the same time, you have a desire to move to newer platforms and newer ways of doing IT. And I don't know a CIO in the world that's at any enterprise that's been around for a while who isn't confronted with this problem. Think of it as old stack and new stack, quite simply. And what you need is a transformation construct. You need governance, business process, change agents, you need staffing and people resources, you need designers and architects, and you need a bunch of talents that you can bring together and really help figure out what the digitization of government really could or should look like. And this comes from user-centered design and a bunch of newer concepts that just didn't exist in the older world. And then working together, the old stack folks and the new stack folks have to agree on here's the sequence and here's how we're going to go transition. And those are the building blocks that we're trying to put in place. And there's no stigma if you're old stack. I mean, that's the stuff that we run on. It's our bread and butter every day. But we got to start the conversation and the movement to new stack, and both sides are going to play a pretty important role in that. And I think it's an exciting journey. It's the reinvention of almost everything we do, and done right, the outcomes are pretty spectacular. It's money saving, highly secure, and much more agile and respondent to the needs of our citizens if we get it right. So I'm pretty excited about the possibilities. All right, well, thank you very much. I appreciate all the work that you do, and we'll look forward to engaging with you in the future.